In the Philippines, just before sunrise on April 23rd, a thermal camera recorded a silent, violent blast. A sudden flash of white-hot energy erupted from the surface of a seemingly placid crater lake, a plume of superheated material punching 600 meters into the sky. This was not a fire. It was not a conventional explosion. This was Taal Volcano, one of the most dangerous and unpredictable volcanoes on Earth, waking up again. The event lasted just 5 minutes, but it was a stark reminder that the serene lake is a lie. Beneath it, a catastrophic force is building. The footage is undeniable. A second, similar blast followed just hours later, and the alert level currently in place does not guarantee safety. It guarantees the opposite. For those in the Philippines who have seen Taal's power up close, or for anyone who understands this region, your perspective is vital. Share what this volcano means for the people on the ground. In the comments, we read every one. Let's begin. The situation is developing faster than many realize. Our analysis shows that a large number of our viewers watch these reports but are not subscribed. To ensure you do not miss critical updates on geological events, like this, 1. It is absolutely essential that you subscribe now and enable notifications. It is the only way to guarantee our next report reaches you in time. We will now continue. This is how it happened. At 5:11 in the morning, the main crater of Taal Volcano experienced a phreatic eruption. This term, phreatic, is clinical. It means steam-driven. But the reality is far more violent. It occurs when superheated groundwater flashes to steam, causing a hydrothermal explosion. It is the Earth clearing its throat, and it can be a precursor to something far larger. By 9:43 a.m., a second phreatic event confirmed the volcano was in a state of agitation. The plume of hot gas and steam drifted southwest, a visible warning sign carried on the wind. The Philippine Institute of Volcanology and Seismology, or PHIVOLCS, the agency on the front lines, has maintained alert level 1 over the volcano. This is not a signal that things are calm. It means low level of volcanic unrest. It is an official declaration that sudden, unpredictable explosions, volcanic earthquakes, and minor ashfall can occur at any moment. But here is the detail that tells the real story. The volcano was screaming warnings for days before the blast. On April 18th, just 2 days prior, sulfur dioxide gas emissions were measured at an enormous 9,677 tons per day. For perspective, that is the weight of over 1.5 million adult men being emitted as toxic gas in 24 hours. That gas is a direct indicator of magma interacting with the water table deep beneath the surface. It is the fuel for these explosions. The crater lake itself was boiling, a pressurized cauldron of acid and dissolved minerals. This eruption was not a surprise. It was an inevitability. And here is what made it so much worse. The community's relationship with Taal is a paradox of danger and dependence. Taal is not just a geological feature. It is an economic engine. The massive lake surrounding the volcano, itself the caldera of a much older colossal eruption, supports a huge aquaculture industry. The lake is famous for its tilapia farms and, more critically, for the Tawilis. This fish, Sardinella tawilis, is a freshwater sardine that exists nowhere else on the planet. It is endemic to this one lake. For generations, fishermen have worked these waters, their livelihoods tied directly to the health of the lake ecosystem. But every tremor, every gas plume, every change in the water's acidity from the volcano threatens their existence. In 2018, the Tawilis was officially listed as an endangered species by the IUCN. The volcano that created its only home is now its greatest threat. A major eruption could trigger a fish kill that would not just cripple the local economy, it could cause the extinction of an entire species. To understand the human stakes, you have to look past the science and into the towns that circle the lake. Communities like Agoncillo, Laurel, Talisay, and Lemery live in the direct path of any potential disaster. They are vulnerable to ashfall, to acid rain, and most terrifyingly, to something called a base surge. A base surge is a fast-moving, ground-hugging cloud of hot gas, steam, and rock fragments. It moves with the speed of a hurricane and the heat of an oven. It incinerates everything it touches. They live with a permanent danger zone in their backyard. The volcano island itself, a 23 square kilometer patch of land in the middle of the lake, has been illegally designated no man's land since the 1970s. Yet people have consistently returned, drawn by fertile soil and tradition, a constant tragic tug-of-war between official warnings and the need to survive. We have seen an overwhelming number of comments from people sharing their direct experiences. Keep adding your perspective. It builds a more complete picture for everyone. What you're seeing here is a pattern, one that has repeated for centuries. The 2020 eruption was a profound shock to the national consciousness. But it should not have been. After 43 years of relative quiet, on January 12, 2020, Taal exploded in a phreatomagmatic eruption, a violent interaction between fresh magma and water. It fired a column of ash and steam 15 kilometers into the stratosphere. For the first time in a generation, ash fell on the capital, Manila, over 60 kilometers to the north. It shut down the country's main international airport, paralyzed commerce, and coated everything in a thick gray film. The alert was raised to level 4, meaning a hazardous eruption was considered imminent. More than 376,000 people were forced to evacuate from a 14-kilometer danger zone. The damage to infrastructure and agriculture ran into the billions of pesos. That eruption fundamentally changed the volcano. The beautiful green crater lake on Volcano Island boiled away completely, leaving a scorched, sterile pit. The island was declared off-limits, a permanent danger zone that was now to be enforced. And for a time, it seemed the warning had been heeded. But water has a memory. Slowly, over months, rainfall and groundwater refilled the crater. The acid lake returned, hotter and more active than before. The April 2024 phreatic bursts are not a new event. They are a continuation of the unrest that began in 2020. This is the new normal for Taal, a state of perpetual instability. Now is a good time to share this report with friends and family, especially those with connections to the region. And if you believe this kind of detailed analysis is important, hitting the like button helps this information reach more people who need to see it. To understand the true danger of what that thermal camera captured, you have to look beyond 2020. You have to go back to 1911. The eruption that year was one of the deadliest in the nation's history. It was largely phreatic and hydrovolcanic, the same type of steam-driven process happening now, but on a monstrous scale. It killed an estimated 1,335 people. The main cause of death was not lava, it was not ashfall. It was the base surge. Eyewitness accounts from the time describe a black, turbulent cloud that swept across the surface of Taal Lake, moving at incredible speed. It hit the shores and enveloped entire villages in seconds. It was a horizontal blast of death. The 1911 event serves as the ultimate cautionary tale. It proves that a steam-driven eruption at Taal can be just as lethal, if not more so, than a classic magmatic one, because it can happen with less warning. The volcano's history is written in devastation. Here is what is not making most headlines. The context of Taal is not measured in years, but in centuries. Its most destructive recorded eruption began on May 15, 1754, and it did not stop for nearly 7 months. It ended on December 5th of that year. For 204 days, the volcano relentlessly bombarded the surrounding province of Batangas. 4 towns were completely buried under ash and rock, their populations forced to abandon their ancestral lands and relocate to where their modern towns stand today. A priest at the time, Father Ben Cuchillo, wrote a harrowing account of the final cataclysmic phase. He described total darkness at midday, constant earthquakes that crumbled stone churches, and a rain of mud and ash so heavy it collapsed roofs. The 1754 event wiped the old map clean. It shows the volcano's ultimate capability, not just a single explosion, but a sustained landscape-altering campaign of destruction. That is the historical weight behind the alert level 1 of today. It is not just about a single plume of steam. It is about the documented potential for catastrophic failure. People often misunderstand the alert level system PHIVOLCS uses. It is a scale from 0 to 5. Level 0 is quiet. Level 1, where Taal is now, means abnormal conditions. It is a warning that the system is unstable. Level 2 indicates increasing unrest. Level 3 signifies magmatic unrest, with an eruption possible in weeks. Level 4 warns a hazardous eruption is imminent within days. Level 5 is a hazardous eruption in progress. The mistake is to see Level 1 as almost safe. The truth is that deadly phreatic blasts can and do happen at Level 1, without any escalation. It is a state of volatility, not a step on a predictable ladder. I know we've asked before, and if a volcano can repeat its warnings, so can we. It is critically important to subscribe. A lot of people find these reports valuable, but forget this simple step. It's the one thing that ensures we can keep you informed when it matters most. Here is what was happening on the ground in the wake of the April 20th explosions. The primary concern immediately shifted to gas emissions. The high levels of sulfur dioxide that preceded the eruption can create a phenomenon known as VOG, or volcanic smog. This is a hazy cloud of SO2 and other volcanic gases that can cause respiratory problems, eye irritation, and damage crops. Following the eruption, VOG was observed blanketing the caldera. The residents of the lakeside towns were advised to stay indoors, wear masks, and protect their health from an invisible threat. PHIVOLCS Director Dr. Teresito Bacocol stated it plainly, saying the eruption was driven by the continued emission of hot volcanic gases, and that it could be a precursor to more similar events. He stressed that the abnormal condition has not ceased. It has not gone away. This is more than just a local story. It's a geological case study in one of the most complex volcanic systems on the planet. People often mistake the island in the middle of the lake for the entire volcano, but the truth is more incredible. The entire system is a volcano within a lake within a volcano. The large Taal Lake fills a massive prehistoric caldera, a depression left by an ancient volcano that collapsed in a titanic eruption hundreds of thousands of years ago. The island in the middle of that lake, Taal Volcano Island, is the active cone. On that island is another crater lake. And in the middle of that smaller lake, there used to be a tiny mound of land called Vulcan Point. It was an island, in a lake, on an island, in a lake, on an island. The 2020 eruption altered this geography, but the mind-bending nesting doll structure of the volcano highlights its immense complexity. The forces at play are operating on a scale that is difficult to comprehend. This complexity makes prediction incredibly difficult. PHIVOLCS monitors a constant stream of data: seismic activity, ground deformation, gas chemistry, water temperature. In the days following the April 20th events, they recorded continuous volcanic tremors, a low-frequency rumbling that indicates the movement of magma and fluids deep underground. These are not discrete earthquakes you can feel, but a constant vibration, the hum of an active and dangerous machine. It is the sound of the volcano breathing. Each data point is a clue, a piece of a puzzle with impossibly high stakes. Dr. Antonia Bornas, chief of the Volcano Monitoring Division, once noted after a similar event, "Even if we say it's a weak phreatic eruption, it's still an eruption. You still have steam-driven explosions that can be hazardous. There is no such thing as a safe explosion when you are dealing with a system this powerful." Now, we come to the final subscribe reminder. There's an old saying in journalism: follow the story. Subscribing is how you do that. It's not about us, it's about making sure you have access to the facts when the next development breaks. It's the most reliable way to stay ahead. Thank you. The official stance remains one of extreme caution. Former PHIVOLCS chief Renato Solidum Jr. has repeatedly stated that Taal Volcano Island is a no-man's land, a permanent danger zone since 1977. There should be no one living there, he has emphasized. And yet the human element cannot be ignored. The pressure to fish, to farm, to simply exist, constantly pushes people back towards the danger. This is the central, tragic conflict of Taal. The government warns of the risk, but economic reality forces the gamble. The island is too fertile, the lake too valuable, to simply abandon forever. This friction between policy and poverty is where disasters are born. The 500,000 people who live within the wider 14-kilometer danger zone are not just statistics. They are families, farmers, and fishermen who must weigh the rumbling of the earth against the needs of today. And it is still not over. The unrest continues. On May 10th, 2024, another phreatic eruption occurred, smaller this time, producing a 300-meter plume. The sulfur dioxide emissions continue to fluctuate, sometimes reaching over 4,000 tons per day. The volcanic tremors persist. The system remains pressurized, and PHIVOLCS bulletins consistently warn the public and local governments to remain vigilant. They reiterate that entry into the permanent danger zone is strictly prohibited. They advise pilots to avoid flying near the volcano's summit. These are not routine warnings. They are a constant daily reaffirmation of a clear and present danger. The question now is not if Taal will erupt again. It is when and what form that eruption will take. Will it be another short-lived phreatic blast? Or will it be the beginning of something larger, a progression towards a magmatic event that could threaten hundreds of thousands of people? The thermal camera gave us a glimpse into the heat engine driving this threat. But the real story is written in the gas readings, the seismic hum, the history of buried towns and deadly surges, and the ongoing difficult choice faced by the people who live in its shadow. The volcano is in an abnormal condition. The crater lake continues to boil as tons of acidic gas are pumped into it from below. The ground itself is trembling with the movement of unseen forces. And every new phreatic blast serves as a reminder that the 1911 and 1754 eruptions are not just history, they are a blueprint for the future.